Rightio. Rightio. Hello all. This video will be a short one. It's just looking at the remainder of the slides from exercise 4E. And we didn't get all the way through the exam question from prior exam, so we're going to look through that. So we had done this bit where we were given this function, and we had to find the coordinates of the turning points, and we were given the function, and we used CAS. This being 2, and I forgot to point it out in class, it says exam 2, which means that's going to be the tech active exam. So you could use CAS for this. You're given the function, so you can put it in, and you can use the min max, or you can use differentiation to find the x coordinates, and then get the y coordinates from there. So we did that. We then were told there's a straight line between between coordinate A and coordinate B. 2 points of the graph F. Find the equation of the straight line through those. And it's, what was it? Between -1. It turned out to be some straight line like that. Okay, and it goes through the origin, because the graph could be considered somewhat symmetrical. So we did that. Then we found the distance AB. Now you could use the norm function in your CAS. You can also use the equation D equals the square root of y2 take away y1 all squared plus x2 take away x1 all squared. That's just Pythag, if you think of it that, between any two coordinates, wherever they are, doesn't even matter if it's on a curve, but the actual distance between them can be broken down into a right angle triangle. So it's just using Pythagoras' theorem and just rewritten like that, which I generally think you're actually given in the formula sheet on the exam. So you could use either the norm function or use this rule, and we could find the distance between the 2 points. Now, this is where we got up to, which we haven't done yet. So we've still got, the function has changed a little bit. We've now got g of x is equal to x cubed minus k of x, where k is some real positive number. So it's any real positive number. Let C be, again, some point, and D be another point. Find the distance CD in terms of k, and now that there's k in here. So again, we have distance is equal to y2 take away y1 all squared plus x2 take away x1 all squared. And in our case, that is equal to y2 is going to be g1 take away g of -1 all squared plus, and we've got 1 take away -1 all squared. So our distance equal to, now we could start subbing in x cubed minus kx into each of those with 1 in there. But again, let's look at using our CAS, and if we define quickly g of x is equal to x cubed minus, we need a variable kx, done. We can then just put that whole line that we've got in our, we can put that whole thing in, and it'll figure it out for us. So class pad, so we want the square root of g of 1 take away g of -1 all squared plus, and 1 take away -1 is just 2 all squared, so we could just put 4 in there and make our life a little bit quicker typing, and we get the distance is equal to 2 square root of k squared minus 2k plus 2 equals 2 square root k squared take away 2k plus 2. There's our distance, okay? Part 2 is find the values of k such that that distance above CD is equal to k plus 1. So we want d equal to k plus 1. So it's quite clear that k plus 1 is going to be equal to that formula we had before, 2k plus 2. And again, we can use our class pad to solve that. So we've now got k plus 1 equals, and we want to do a bit of a solve actually. Solve k plus 1 is equal to, we just highlight above, drag it down, okay, and we're wanting to figure out what k is, so comma k, and we get k equals 1 and k equals 7 on 3, k equals 1 and k equals 7 on 3. So that's that bit. Part D. Okay. The diagram below shows parts of the graph G and Y equals X. These graphs intersect at the coordinates 0, 0 and A, comma A. So G of X is still X cubed minus KX. And then we've got Y equals X, and it's just find the value of A in terms of K where these intersect. So we're just finding where the two equations intersect. So we're going to let X equal to X cubed minus KX. And we want to solve that. So again, let's go solve X equals X cubed minus, we could just type in G of X since we defined it earlier. And what are we trying to figure out? We're trying to figure out where they intercept, which is effectively, even though it says here find value of A in terms of K, we're actually trying to find the x-intercept, the x-coordinate of the intercept. So we're trying to figure out what x is, and close that, and we get x equals 0, negative square root k plus 1, and then k, negative square root k plus 1, and also square root k plus 1. So that's the values of where the intercepts are. Now, clearly x equals 0 is at the origin. This negative square root of k plus 1 is actually if, because you've got to think the actual function, when not restricted like this, has another intercept over there, and then we actually have this one that we hear. So we actually reject that, and we reject this one, and we say A is, because we had to find the value of A is equal to the square root of k plus 1. So that's that problem done. So nice short video, 8 minutes, just going through the remainder of that exam style question. In our next video, we'll start looking at polynomials of higher degree. So we'll be looking at quartics.